So in an alternating current, so we have certain important definitions or the terms what we use whenever we solve a problem or any other derivation. Okay, so of the terms, one of the most important terms is an RMS value. Okay, or we also call it as root mean square value. Alright, or we also call it as a virtual current. So now we have to know what is an RMS value. Alright, so it is that steady current which when passed through a resistance for a given amount of time and the heat produced by it is the same amount when an alternating current is passed through the same resistance through the same amount of time. Okay, so RMS value is basically the heat produced. Okay, so whatever the heat produced by the resistance when a steady current is passed through it and the heat produced by the alternating current for the same time and through the same resistance. Okay, so we are going to compare this and mathematically we are going to derive the relation between the RMS value and the peak value of an alternating current. Okay, so let's start with the derivation. See, first what we have is some current, let's say I is equal to I naught sine omega t is passing through a resistor. Okay, see here I naught is the peak value and then omega is the angular frequency. Alright, so see here the alternating current changes every second, correct? Every second, as the time is changing, the alternating current also changes. So what we have to take is, let's say at some instantaneous time dt, okay, at some time dt, let's say dH is the heat produced. Okay, so we have dH is equal to I squared R dt. Okay, so I believe you guys already know the equation, H is equal to I squared RT. So using that we are getting this. Okay, so I value is what? I naught sine omega t. Now substitute that. You will get I naught sine omega t whole square into R dt. So you will get I naught squared into R into sine square omega t dt. Correct? Okay, see here the amount of heat produced here, it is for very small time dt, correct? Now we have to integrate it. Fine. Now the limit for the integration will be 0 to t by 2. Okay, now why t by 2? Because in an alternating current, so from 0 to t by 2, that is for half the cycle we are considering, because the other half it will be negative, correct? So from 0 to t by 2 we have to consider, that means the heat produced in that time period. So we have H is equal to, so integral of 0 to t by 2 I naught square R sine square omega t dt. Okay, so here I naught squared R is a constant, so we take it outside. We get I naught square R integral of 0 to t by 2 sine square omega t dt. Okay, now sine square omega t, if you have to integrate, so we need to convert it into cos 2 theta formula. Okay, so we have 1 minus cos 2 omega t by 2 and then we have to integrate that. So that will be nothing but I naught square R integral of, so 1 by 2, that's basically 1 by 2 if you take it outside, that will be just dt minus 1 by 2 cos 2 omega t dt. Correct? Okay, now sorry, so what we have is I naught square R by 2 into integral of 0 to t by 2 dt minus integral of from 0 to t by 2 cos 2 omega 2 cos 2 omega t dt. Okay, fine. So dt, if you integrate you will get t. If you substitute the limits you will get t by 2 minus 0, which is nothing but t by 2. Next, cos 2 omega t, if you integrate, that will be nothing but sine 2 omega t by 2 omega. Now if you substitute the limits from 0 to t by 2, that will give you 0, because sine 2 omega t, so when you substitute the limit, sine 2 omega into t by 2, so it's nothing but sine 2 pi by t into t. So you'll get sine 2 pi. Sine 2 pi is 0. So 0 and then sine 0 is 0 anyway. So the whole term becomes 0. So final answer will be nothing but h is equal to I naught square r by 2 into T by 2. Correct? So what we get is the heat produced will be h is equal to I V square r into T by 2. Okay, so this is basically the heat produced by half a cycle of an alternating current. Okay, now the steady current is flowing for the same time. So we have h is equal to I naught square r into T. Correct? Equating these two, we have IV square RT by 2 is equal to I naught square R by 2 into T by 2. So here R, T and 2 will get cancelled. Correct? So you will end up with IV square is equal to I naught square by 2. Okay, now if you take square root on both the sides, you will get, see, IV is equal to I naught by root 2. Correct? So 1 by root 2 value is 0.707. So we have IV is equal to 0.707 I naught. That means the RMS value or the virtual value of an AC is 70.7% of the peak value. Okay. Now similar way we also have E is equal to E naught divided by root 2. That means the RMS value for the EMF. So EV is equal to E naught by root 2. Okay. So this is the complete derivation of how we get the RMS value. Okay. So in the next video you will see few problems based on this so that you guys will understand what is the RMS value.